Here in Chapter 11, we're going to be taking a look at the single case, quasi-experimental, and developmental research methods. These are some research methods that are used with populations that it's either unethical or unreasonable to make a random assignment. So we're going to use the existing characteristics of the individuals, or in some cases, like in the developmental research design, where we want to track changes over time among people that have certain characteristics. And we can't do that very well in an experimental setting, so we use the quasi-experimental setting. So let's take a look at some objectives and maybe talk about some of these definitions and then getting into some of the designs. Some of the things that we're going to cover in this chapter are describing the single case experimental design and discuss reasons to use this design. So the single case experimental design is kind of like a group assigned experimental design. The difference is that with the single case, you don't have a lot of different data points to compare. So even though it's an experimental design, don't confuse it for an experiment itself, where we're using something like a double-blind procedure, random assignment, etc., etc. We're going to talk about one group and post-test only designs. We'll talk about the associated threats to internal validity that occur with those particular designs. We'll look at the non-equivalent control group design and the non-equivalent pre-test, post-test design. So we'll be adding an element to the one group post-test only or pre-test, post-test design. We're going to be able to distinguish between the interrupted time series design and a control series design, which is a very interesting way of looking at data over time, and the difference between those is fairly obvious. You'll see when we get there. And we're going to talk about cross-sectional, longitudinal, and sequential design analysis and describe what's called the cohort effect. So jumping into this, we're going to talk about the single case experiment. And it's important that we start here because it's fairly simple. You may have heard this as a case study, but it's a little bit different because in a case study, we're generally observing the changes that would happen naturally. We're just watching what would happen. As opposed to a single case experimental design where we are implementing some kind of intervention. So think of having an individual, like a child, a child growing up in a home is a continuous single case experiment to where you're monitoring some kind of behavior, you introduce some kind of intervention, and then you monitor the behavior again to see if it changed. And if the behavior changed, then the intervention worked. And if the intervention does not change, then if the outcome or the behavior does not change, then the intervention probably does not work. So what we do is we observe behavior over a period of time without any kind of intervention. So let's say that we have a child that is overly demanding. So they're impatient and they demand things. We can watch and see how many times per day that child demands something. And we can keep track of that over a few days. Then we can introduce some kind of behavioral intervention where we ask the child to be patient, and then they're rewarded with praise after they're patient, and then we track how many times they're demanding over the next few hours. The idea is that after we introduce the intervention, a praise response, if the child is patient, then it will decrease the likelihood that they are going to be impatient and demanding. So what we want to do is track very carefully the behavior that we've defined, whatever it is. We have to have an operational definition for the behavior. We introduce an intervention that's likely to reduce or increase the behavior depending on what the behavior is. Sometimes you want to increase behavior, right? And then after the intervention, we track to see what our original behavior looks like in terms of the frequency or intensity or whatever we're measuring. If we do that, it's called a reversal design, where we are tracking some kind of an intervention over time, and we want to know if the introduction of that intervention reduces behavior and if the removal of the intervention increases the behavior, if we're talking about, again, the example with the child with the demanding behavior. So ideally, introducing some kind of intervention will reduce demanding behavior, and if you remove that intervention, we would expect the behavior to go back to what it was before. Now, that's the goal, just to test to see if the intervention works. Obviously, we want the intervention to lead to permanent change. But in terms of testing the intervention itself, all we need to do is show that during the time that we're using the intervention, it reduces the behavior. So we use some letters for that, and we call this the ABA reversal design. The baseline behavior without any intervention is labeled A. The treatment is labeled B, and the baseline again is labeled A. So we would have baseline behavior where there's no intervention, where we're not praising the child for being patient with us and not demanding. Then we begin to praise the child for being patient and not demanding. So that's the treatment, and we would expect the behavior to decrease during the treatment. And then once we've seen a decrease in behavior and it's kind of stable, or it's become stable, it's leveled off, then we will remove the intervention. So we will stop praising the child for being patient and non-demanding, and we would expect then the behavior to go back up, unless there happens to be permanent change, but generally it doesn't happen that quickly. We can extend this design to ABAB, so we can continually rotate between the baseline and the treatment. So baseline, treatment, baseline, treatment. We could also introduce a type of behavioral intervention that might be aimed to reduce the behavior, if we're using the same example with the demanding child, but it might look a little bit different. So instead of just giving them praise, we tell them that if they are not demanding all day, then maybe they can go to get some ice cream or something. So that could be a different type of intervention. Maybe it's A, B, A, C. So you can have the letter C indicates another type of intervention. A always stands for the baseline, but the B, C, D, whatever is a different type of treatment. So if we wanted to change this, let's say that we added in A, B, A, C intervention. Let's go back to the baseline afterwards. So if we had something that looked like this, then we would have a baseline behavior where we're watching the child and we're monitoring the number of times the child is demanding. Then we begin to praise the child for being patient, hopefully to reduce the occurrence of demanding behavior. And then we go back to baseline where we're just observing the child and not using any intervention. And then we use a different intervention. We say, okay, if you don't beg me to do whatever you want to do, then we'll go get ice cream later on today. And then we track the number of demanding behavior that the child has, and then we can remove any treatment and go back to a baseline to see if the behavior goes back to what it was before. So we can use these as a way to track which interventions work better. This is just a simple reversal design, and it means that we go from baseline to treatment and back to baseline again. Here's some data that I pulled from the book that kind of outlines this idea. Let's say that we want to know if a skilled teacher can increase the amount of correct homework problems. So what we can do is we can have somebody who basically knows, let's just say it's math. Let's say that somebody basically knows math. They graduated from high school. They've taken some algebra classes and things like that. And they're going to work in a 5th grade classroom to teach them maybe long division. So in the first few days, the person who is untrained but still has information about math is able to have the students get, from 0 to 1 problems correct on math homework. Maybe it's out of 10. Probably it's really not good, but here we are. We're teaching kids how to do something. They're an unskilled teacher, so what do they know? And then we have somebody who is skilled to teach and to teach mathematics. They come in over the next several days, and the number of times that the students get a correct problem, let me start that over. The number of correct problems that the students have increased significantly to around 6 or 7 over the next 5 days. And then you reintroduce the teacher who was in the first situation, so the unskilled but knowledgeable person, and the number of problems goes back down because their teaching skills probably aren't as good as the teacher who was trained to do their job. So we can see that we have a baseline, that we have an intervention using a skilled teacher, and then the baseline again, and you can see that there is a clear change overall. Now, what's important to know about when we do a reversal is that we don't want to do a reversal too soon, because we need to get some data to see a trend here. You can see during the first baseline phase that there is a trend. The data kind of stays between 0 and 1. And then we see another trend that starts to plateau during the treatment phase. And then once we see that pattern, then we can go back to baseline and we see another pattern emerge, which is kind of like the first one, where there's kind of a 0 to 1 number of problems correct trend that happens. We would not want to create a reversal at this point because there is no stability in the data. It's going up. We don't see a plateau. So we want to definitely wait until we see a trend before we introduce the baseline, or before we change phases altogether. There are some cases where it is useful to use what we call multiple baseline designs. So with multiple baseline designs, we can observe change under multiple circumstances, which we'll talk about in a moment. We can introduce manipulation at different points of time, which is the most important aspect for the multiple baseline design. It allows us to determine if there is a difference in when we introduce some kind of treatment. And then we can also determine if manipulation is the cause of the change. So let's say that we had a group of 25 students in a classroom and we implemented a change after lunch. So whatever it was, we were measuring some kind of behavior. Maybe it was noisiness. And after lunch, we decided to say, okay, for the first half of the day, we're going to use a baseline. But after lunch, we are going to say that if the students are quiet, then they will get 5 minutes more recess in the afternoon. Well, the problem with that is that after lunch, children are generally quieter anyways because their bellies are full and they're probably a little lethargic because of the natural diurnal cycle that happens biopsychologically. So we would make a mistake if we thought that just implementing something after lunch was the trick. What we could do is we could implement our baseline by having maybe several classrooms. And one classroom, you implement the intervention at the beginning of the day. Maybe the second classroom, you do the intervention around 11 o'clock or so. Then the third intervention, you might do around 1 o'clock. And you can tell if the intervention makes a difference at certain points of the day that are different than others. We'll take a look at an example of that from the book. But the idea here is that we can isolate the cause of the intervention. If the intervention does have a cause, we can do that by finding if there is a difference in when you implement it throughout the day. If there is a difference in when you implement it throughout the day, then maybe the intervention is not the cause. Maybe the time of day has more to do with it than the intervention itself. If the intervention has the same effect no matter when you implement it throughout the day, then you can probably say that that the intervention has more to do with it than the time of the day or whatever other confounding variable you're talking about. There are 3 different kinds of situations where we implement multiple baselines. One is across subjects, so we could see if an intervention works with different types of people. For example, we could see if a candy reward system. So if you're in a school setting and you have a classroom and you say, we're going to reward you with candy if you are good throughout the day. And you could see if that intervention works with first graders, fifth graders, and high schoolers to see if there is a similarity or a difference in how those individual subjects or the classroom subjects would respond. You could also have multiple baselines across behaviors where you're trying to modify several behaviors at once, where you could reward, let's say, something like quietness, so being quiet or attentive, maybe being attentive in a classroom. And you could also implement a change that would help them to help reward something like homework completion. You could then have another behavior that you're trying to reward that is something like being kind or polite, some of these positive character traits. So you could reward these selectively throughout the day to see if a reward system works across multiple behaviors. And then you could have multiple situations. You could see if a reward system that you implement in school has the same impact as if you implemented it at home. So maybe you could be trying to modify the same behavior, like staying on task by completing homework at home and by completing the in-school work in school. So you could try the same interventions in those 2 different situations to see if there's a similarity And if there is, then maybe you can say that the intervention works across multiple situations. If it doesn't work, then maybe you can say that the intervention doesn't work in a certain situation, or you can say that the intervention works better in one than the other, even though there is some increase if you're trying to increase time on task, for example, at home. So the way that we implement these multiple baselines is just selectively for the type of research that you're doing. You don't have to seek out a particular design. Remember, all these designs are based on the research questions that you have. So you would select one way to implement your intervention based on the kind of research question that you have. This is an example of using a multiple baseline design across 3 subjects. And what we're trying to do here is reduce the number of cigarettes that people smoke based on some kind of treatment. It doesn't matter what the treatment is, it's just a treatment. And the idea here is to see if the intervention first works across different subjects, also if the intervention works across different times that they're implemented during the study. So maybe a hypothesis is that the longer you wait to implement the intervention, the less likely it is to work. Let's just say that's a hypothesis, and that's why they set it up this way. So in each case, the baseline is introduced at different points in time for each of the subjects. And as you can see that when the intervention is introduced, there is a sharp decrease in the amount of cigarettes that are smoked for each case. What you can also notice is that, with the exception of the first case because they implement it so soon, there's a general trend that's happening. However, in this last case, you might reconsider if you're going to introduce the intervention after day 9, because there appears to be a slight downward trend. And you might think to yourself, oh wow, this person's smoking less, that's a good thing. Yes, but they're also being observed. And we know that with reactivity, people might engage in what's called social desirability if they are being observed. So they might be stopping smoking on their own just because somebody is watching them. Now, I would be concerned about introducing a baseline here, but it's perfectly fine for the sake of this, because they probably set up the design so that they introduced it after day 3, after day 6, and after day 9. And that's just what they went with, regardless of what the trend was looking like. As you can see, they all have sharp decreases, except for in subject 3, there appears to be a little increase afterwards. Again, we don't know what this trend is going to look like afterwards. We don't have the data for it. So what we can say is that it appears that the treatment has some kind of effect after it is implemented for some period of time, even if it's just for a few days in the last case. Now, with single case experimental designs, we were looking at tracking one person or a small group of people over time. In a quasi-experimental design, we are looking at grouping people somehow to the best that we can, but usually using existing characteristics. Like, we want to know if there is a difference between people who are in public school versus a private school. Those are existing characteristics. We can look at the difference between those two. We can also use a quasi-experimental design in kind of a naturalistic setting. We're going to look at an example that is a naturalistic setting, but it uses a quasi-experimental design, meaning that there are some characteristics of an experimental design to where there is some control, there is some independent variable, there is some dependent variable, and you're going to measure it. However, when you have the independent variable, it can't be manipulated. For example, we're going to look at a situation where somebody sits down next to somebody on a bus to see how long that person takes to get up and move away. That the independent variable is still present. It is sitting. But it's not manipulated. You know, you're sitting next to somebody, and maybe you could have a variation of it that says that we'll sit 1 seat versus 2 seats. But for the sake of this experiment that we're talking about, they're sitting right next to them. That's not a variable. That's just what is happening. So it's still an independent variable by definition because it is leading to an outcome, but it's not something that's manipulated. The internal validity in the quasi-experiment is affected significantly because there are a lot of things that we can't control. In an experimental design, we want to try to control everything that we possibly can, and because we are leaving a lot of things to just nature, just how things happen, and not controlling for the characteristics of the person who is in the study or anything, it becomes quasi-experimental. There are a couple different designs. We're going to start off by looking at the one group post-test only design. So with the one group post-test design, we're lacking a comparison group. We're just having one group that goes through an intervention and measuring the outcome, and that's it. That would kind of be like giving a classroom an exam. I would say I'm going to give you an exam to see how well you know the information. The exam would be the intervention, and then the outcome would be whatever your score was on the exam, and that's it. I'm not comparing you to another group of individuals. I'm not testing to see what you know before and then teaching you something and testing you afterwards. It's simply one group doing one intervention and measuring to see what the differences are. The problem there is that it's difficult to draw a causal inference about the variables. I can't say necessarily that what I taught you leads to the outcome. But what it is good at doing is measuring how people naturally learn something. So there is a trade-off there. We are trading off the causal inference for the ability for us to say that the results that we found are probably something we'd find in everybody else, or something that's generalizable. Here's an example that I referred to earlier about the one group post-test only design. We have some participants, and they sit next to a stranger, which is kind of the independent variable, although it doesn't vary much. And then the dependent variable is the measurement, or the time until the stranger leaves. So we could just sit down next to somebody, see how long it takes for them to get up and leave, and measure that. We wouldn't be able to say that we caused them to leave, because they could have had something else that they were leaving for. They could have gotten a phone call. There could have been time for them to go to an appointment or whatever it was. Maybe their lunch break was over. Who knows? So there is a very obvious description of the one group post-test only design. There's one group, so some participants, maybe we had 10 people go out and do this. There was a post-test only, meaning that they didn't sit down to a stranger first to see how long it took them, and then they sat down next to another stranger, and then we timed them again. That would be kind of silly for this example. They sat down next to one stranger and then measured something. So it's a post-test only. They only looked at the outcome or the test outcome after they went through the intervention, after they created the experimental condition. So with the one group post-test only design, we don't have a pre-test, but there are cases where it's reasonable to have a pre-test. We call it a one group pre-test post-test design, where we're going to measure an outcome and then do an intervention and then measure the outcome again to see if there is a difference. An example of this might be a simple pre-test, post-test for a chapter of material. Let's say that I gave you all a pre-test on chapter 11, this chapter, and I said, what do you know about this pre-test? You kind of did this through the comprehension quiz, by the way. But I said, what do you know about this before we go into it? And I measure your scores, and then we go through a lecture, and then we measure the scores again. And we might see a difference between them. That would be a one group pre-test, post-test design. And it is still quasi-experimental because I'm not controlling a lot of things. I'm not controlling your ability to go through the chapter on your own. I'm not controlling your ability to look at the information on the lecture beforehand. I'm not doing any of that. I'm only testing you before and after, and there's a lot of variables that I'm not controlling for. That's why it's a quasi-experiment, because I'm not controlling for all those other variables. Also, you are a pre-selected group of people. And because you're a pre-selected group of people, I'm not taking the time to randomize you into different groups and controlling one group versus an experimental group, etc. All I'm doing is using one group with whatever characteristics that you already have. I'm not controlling a lot of variables, and I'm measuring you before and after I've provided you an intervention, which would be the lecture. There are some problems with this design, though. I say problems, they are considered problems, but really they're just considerations. One of them is called a history effect. Sometimes we can have something that happens at the same time during treatment, and that can be problematic. For example, let's say that it's last spring semester, and I want to do a pre-test and a post-test on some material. And let's say the pre-test was before spring break, and the post-test was going to be after spring break, after we had come back and I'd done a lecture on the material. Well, last semester we didn't come back from spring break. You just kind of got left hanging wherever you were in the world. So there would be a history effect. Something happened. that led to a change in the outcome. Even if I give you an online lecture and a pretest, that would impact everything because it's not this traditional classroom setting that we were used to. There's also something called the maturation effect, where something changes systematically over time. So let's say that that I were to give you a pretest and then a post-test, and the post-test would happen after a lecture. But let's say that you went to tutoring between the pretest and post-test. You learned something new, you grew, you matured in your understanding of the material. So that could be something that changes systematically over time for you and not other people. Think of something like athletics in a middle school classroom. Let's say that I wanted to measure the distance that you could throw a ball. And I measured the distance that you could throw a ball in 5th grade and then in 6th grade. For many people, there would just be normal developmental changes, but for some children, they might go through a growth spurt between 5th and 6th grade, and their scores are more related to a larger growth spurt than just regular development that happens through coordination and regular strength. So the maturation effect would be that there was something that changed in some children systematically more than others, and that would be a problem with any kind of pre-test, post-test design, but especially when it happens over time. There could be a testing effect. When you take a long test like the GRE or the SAT, generally there is a practice section. So you get to understand how to take the test or what the questions are going to be asked of you. Even if you don't have those on the test, you have access to tests online that you can go and practice with as well. But the idea is that there are some testing effects to where you are sensitized to the type of test, and that increases your ability to perform. So, for example, let's say that I was going to measure how fast you could run a mile each week. Well, geez, that sounds like an awful boring thing anyways. But let's say that I did that. And as I was testing you, you were learning strategies to run better, to pace yourself better and everything. So what was happening is that I wasn't really measuring your ability to get faster. I was measuring your ability to learn how to pace yourself for a mile. So it's not a matter of necessarily physical fitness. It was just a matter of you conserving energy. So you learned how to take that test, which led to the overall change. Another issue that happens in the one group pretest post-test design is instrument decay, which means that something happens in the instrument that makes it not work over time. So let's say that I developed back in 1970 a really cool, I wasn't alive back then, calm down. In 1970, I developed this instrument to measure how much people use technology in the world. And back in 1970, we're talking about like maybe a pocket calculator, which really were not pocket calculators at all, or maybe using maps or something like that, or digital readouts on a microwave or something like that. Really, really simple stuff. And I developed it, and it had questions like, how often do you use a calculator versus using a slide rule, or a calculator versus pen and paper? And I asked that question back in 1970. And then I used that same instrument to ask that question of students in 2020, 50 years later. Wow, 1970 was 50 years ago. That sounds incredibly crazy to me. So I asked that same question in 2020. The instrument's not going to work, because there isn't going to be a comparison between calculators, pen and paper, and using a slide rule to do a math problem. So the instrument decays. What can also happen in instrument decay is observations made by the researchers. Let's say that I am going to measure or count the number of times that a child engages in aggressive behavior in a classroom. I am an instrument. I am measuring that. And let's say over time, I get sensitized to what that behavior is. So I used to think that in order for it to be aggressive behavior, somebody would have to haul off and whack somebody. Okay. Now I know that somebody, all they have to do is maybe grit their teeth and squeeze their hands or something like that. And I think that, okay, now that I know that people, all they have to do is grit their teeth and squeeze their hands, I'm going to measure that as aggression, whereas before I didn't measure that as aggression. It could work in the opposite direction too, to where I think that somebody using, maybe a balled up fist and gritting their teeth, that's not aggressive, because I've seen people bite other people and hit them or throw something at them. That's really aggression. So in that case, the instrument, my observations have decayed, because all of a sudden I don't perceive the same stimulus as being aggressive that I used to. So the instrument can decay. And the last is regression toward the mean. Usually what happens is that if we have a lot of different scores, they could have a lot of variation, but overall the mean stays the same. So what happens over a lot of time and a lot of observations, there is not a lot of change. Let me take you back to the example here. So if we have this baseline behavior here, we see that there is some significant change here. That over 3 days, there is a change in maybe 20 cigarettes used. That seems to be a lot of change. But let's imagine for a second, maybe I'll draw this on here. Let's imagine for a second that this trend continued to be like this. Now, that might look like a lot of variation is going on, but what's really happening is that there is this overall stable trend that kind of flattens out. So everything tends to be between those two lines. Well, ish, I kind of drew them poorly. But those two lines there, I can cheat. Boop, you can move a line. So everything stays there. So even though there is some variation in here, the general regression or the general trend stays in the middle. And that's what happens over time. Now, in this example down here, get my marker back out. In this example here, we have a fair amount of variation that happens over time. So even though there is, what appears to be smoother lines, there's more variation that happens from the first and the last trend. And when that happens, there's a little bit less regression, but still overall, you can notice that there is some stability in the measure overall. When we talk about regression toward the mean, we're talking about something that happens in pretest, post-test designs when you have multiple measurements over a long period of time. This is another example of a pretest, post-test design, and this kind of goes along with the example from the single case that I just showed you. But it has some participants, one group of participants only. We assume that they're smokers. The dependent variable, we're going to measure how much they smoke now. We're going to go through a training program. Then we're going to measure how much they smoke later. This is kind of like a baseline design, an ABA reversal design, except for we're not going to take away the training program, ideally. It's kind of unethical, because if it makes a positive difference in smoking, then we shouldn't withdraw that training program, right? Right. So that's just a one group pre-test, post-test design. A little bit more sophisticated than that is when we use a non-equivalent control group. So there are two different kinds of non-equivalent control groups, meaning that we have two groups of people that may not be similar to one another. If we wanted to make the groups similar to one another, we would separate the two groups out randomly and just have them go, one group is number one group is number two, randomly assign people to that, and we're off to the races. The problem with that is that we can't randomly assign people to groups in some cases. Let's say that we wanted to see if there is a difference between first graders and seventh graders in terms of how they respond to a behavioral intervention. Well, we can't very well randomly assign people to first and seventh grade. They are already in first and seventh grade. So those two groups will be non-equivalent. There is some characteristic that naturally separates them. In a pretest, we can determine if the groups are different to begin with. And if we use like a first and fifth grade or a first and ninth grade, whatever it is, grouping, there's probably going to be some differences between them. That's what we can measure. Then we can see if there's an overall difference after the intervention has been produced. Now, there are some things that we can do with a non-equivalent group to make them a little bit more equivalent. So instead of just saying we're going to use first graders and ninth graders to see if there is a difference in how they respond to a behavioral intervention, we can say we're going to use first and ninth graders, But what we're going to do is we're going to ask them questions about them. For example, we're going to find out what their socioeconomic status is. We're going to ask if they have parents that are still married, et cetera, et cetera, et cetera. We could ask all those questions, and we could then select people from each group that have the same kind of responses as the other. So we could find some first graders that had an intact parental group that were kind of middle class, making between $40,000 and $70,000 a year as a household, something like that. So we could use what we call propensity score matching by grouping people based on some characteristics. And we can help to make those non-equivalent groups a little bit more equivalent. So we can just go from comparing first and ninth graders generally to finding first and ninth graders who share some characteristics. So let's take a look at an example of a non-equivalent groups design. Very simple. We can have some participants that go through a training program, and then we can measure how much they're smoking. Then we can have some smokers go through a not training program and measure their smoking as well to see if there is a difference. We can use a control group design the same way. The non-equivalence pretest post group design the same way, where we have a measure before the treatment and then after, and we can see if these measures are the same or if they're different. And ideally, we would have similar measures at the start, because so far there's no treatment. So we would have smokers that we would be measuring, and then we would give one a treatment and one not a treatment. Then we'd measure them again, and ideally they'd be different, and that would indicate that hopefully the treatment group had a lower smoking score. When we're talking about quasi-experimental designs, we've talked about the pretest, post-test groups, non-equivalent pretest, post-test groups design. We can also talk about using something called an interrupted time series design, which is where we watch a behavior for a long time, and then we introduce an intervention, and then we track to see if the changes made a difference. The problem with that is that the longer we go through a study, the more likely there are to be other things that are impacting the study that we're not controlling for. So in an interrupted time series design, we want to examine a dependent variable over a period of time before and after an intervention has been introduced. Sometimes there is interpretation problems, and like we've talked about before, there is some regression to the mean, meaning that over a long period of time there could be some variation, but generally it stays within a certain range. We can overcome some of those issues by using what we call a control series design. What we do is we find an appropriate control group. So we might find a group of I can throw an example out there. Let's say that we want to help reading scores for people that have reading difficulties. So whether it's literacy, whether it's something else like dyslexia, pardon me. I was at a loss for words for a moment. Or dyslexia or something like that. We could monitor their reading abilities for a while, introduce a reading intervention, and then we could track their reading again to see if that helped with reading scores. We could use another group of students that don't have any kind of reading impairments or disabilities or difficulties, and we could run them through the same program to see if it made a difference for them. And we could use that control group to determine if there is a difference in the reading scores before and after an intervention. The control group doesn't even have to go through the intervention, as long as you recognize that you're measuring something before and after a point that the other group received an intervention. Let's take a look at an example of an interrupted time series with and without a control group. So in this example, we're going to take a look at traffic fatalities in Connecticut from 1951 to 1959. So these are the number of traffic fatalities, and there was a spike here, and then it decided to go down. Well, let's see what happened. There was a treatment effect that happened. And let's say that the treatment effect that happened was because seatbelt laws were introduced and seatbelts were required in vehicles. If that's the case, then we could probably confidently say that when the year that seatbelts were made mandatory, traffic fatalities began to go down. Now, they still hadn't gone down to the point that they were back in 1952, but they were on a downward trend, whereas before they were on an upward trend. This is a very simple time series design, and there is some kind of intervention that occurs during that time period that gives us some reasonable assurance because of the interpretation of the downward trend that the intervention had an impact. Now, what we don't know is this a different trend than if another state hadn't had this intervention? So let's say if there was another state and we wanted to compare these traffic fatalities to that one to determine if this treatment was different than if there were no treatment but in a different state. Let's take a look at that. There are 4 other states that we're looking at here. So 4 other states have an average traffic fatality rate, and we're looking at rates now as opposed to the numbers, which is a fine comparison. It's okay. So the rate of fatalities for those 4 different states appeared to stay stable over the same time period that the traffic fatality rate in Connecticut began to go down. So because of this, we can see that after the intervention, which is indicated by the dotted line, traffic fatalities began to go down. Now, they started to go down also in these other states, but it is possible that there was some carryover. Let's say that Connecticut says, well, we're going to make seatbelts mandatory. And the other states other people in the state started to think, well, wait a second. If this state is saying that we should have seatbelts implemented and they start to see a downward trend, maybe we should wear seatbelts too. And maybe they started to see a downward trend as well, but not at the same rate that as if they were made mandatory. Boy, it kind of sounds like something about masks and COVID-19 and things like that. Not trying to make it about that, but there's an interesting parallel there, right? Okay, moving on. Developmental designs. When we talk about developmental designs, we're talking about watching a particular group of people over a period of time or a cohort over a time over some time period. So let's take a look at 3 different types, and we'll look at some examples of each. Developmental designs come in 3 basic flavors: cross-sectional, longitudinal, and sequential. A cross-sectional method is where we look at people of different ages that are measured at some point in time. So a cross-sectional method is done at one point in time, but using several different ages. For example, if I wanted to know what the attitudes of Olivet College are for freshmen, sophomores, juniors, and seniors, I can use a cross-sectional method by at one point in time surveying freshmen, sophomores, juniors, and seniors and asking them what their feelings are about Olivet College. I could get all that data at one time. Longitudinally, I could look at freshmen during their freshman year, then ask them again at their sophomore year, then ask them again at their junior year, then ask them again at their senior year. So I would be observing them throughout each time period that I'm concerned with. I could use a sequential method where, and bear with me, this is a little bit cumbersome to describe because it's combining the two, but here's what I could do. I could look at the attitudes of freshmen and sophomores now, and then I could look at the attitudes of freshmen and sophomores when they are juniors and seniors. So I would be getting 2 different time periods, but I would be getting a representation of freshmen and sophomores and juniors and seniors by doing that. So what it does is it overcomes one of the limitations of the cross-sectional method, which is that in a cross-sectional method you don't get the opinions of the same people from time to time. So there is some validity concern there. But with the longitudinal method, you can get things like cohort effects, which are when a group experiences the same kind of thing. So if I ask seniors how they like their senior year, that last year they probably would be unhappy with it because of the way that COVID ended things. So there would be a problem there. So in a longitudinal method, we also are concerned with keeping the same people in the study from time to time, which can be difficult to do. So a sequential method kind of takes both of those methods into consideration and tries to reduce the impact that each of the limitations has on it. Here's an example from the book of what a cross-sectional method might look like, what a longitudinal method might look like, and what a sequential method might look like. So let's say that we're interested in knowing something about people who are in group 1, group 2, and group 3, but we want to know about something that's going on with 55-year-olds, 60-year-olds, and 65-year-olds. Maybe we want to know about their opinions on Medicare. We want to know what the Medicare is looking like for them and what their interests and concerns are in it. So we could ask a 55-year-old, 60-year-old, and a 65-year-old all at the same time. We'd be getting a cross-section of 50 to 65-year-olds by doing that all at one time and not having to wait 10 years to do it. Then we have a longitudinal method where we could ask the people who were born in 1955 what their feelings are at age 55 and then 60 and then 65. The problem here, again, is that we have to get the same people to stay engaged in a study for 10 years, which can be difficult. Or we could use a combination to where we could use one group of people who were born in 1955 and ask them at ages 55, 60, and 65, and then ask a group that was born in 1945 at 65, 70, and 75. So what we're doing here is within a 10-year span between 2010 and 2020, we are asking people who are 55, 60, 65, again 65, 70, and 75 years old what their opinions are in a particular matter. So we're getting a spread of 20 years of data consolidated into only 10. That allows us to get a lot more information out of it than we would otherwise, because we wouldn't be able to have probably a lot of people stay in a study for 20 years from 55 to 75 years old. So some benefits of the cross-sectional method is that it's relatively cheap and allows comparisons to be made quickly. We can do a study of 10 years worth of time in a very short amount of time. The researcher can only infer, however, that any differences are found are due to age. Okay, so we can't say that it's an experience that each group had, because they all have different experiences. And the problem is that the differences might be due to a cohort effect again, because when we have a cohort effect, it's because some groups experience things the same way that are different than groups who do not experience that thing. The cohort effect can impact the cross-section too, the longitudinal study, as I mentioned before. The longitudinal method is a way to study conclusively the changes that happen to people as they age, so we can look at how people age without having to worry about the fact that we're looking at cohorts instead of one group over time. It does help to control for a cohort effect, but when we do try to compare two longitudinal studies, like if we wanted to compare 75-year-olds over 10 years, and then we wanted to compare 75-year-olds over 10 years, but in Asia, there might be differences between those cohorts, but generally within a cohort, there is not or between a group, there is not a lot of cohort effects, unless you're comparing them together. It's expensive and difficult to carry out a longitudinal study because it takes time and intentionality for somebody to track changes over time. And obviously, it takes a long time to yield the results. The sequential method takes less time and effort than a longitudinal study, but still more than a cross-section. It yields some results right away. So if we have a longitudinal study, and I'll go back to the slide on that. If we have a longitudinal study where we are looking at two groups of people and we want to know what their experiences are like over 10 years, during the first time that we take data, we already have two data points for 55-year-olds and 65-year-olds. So we can get some data relatively quickly. We get some information on people as they change across their lifespan, but obviously, if we're doing sequential method, we're going to miss some data. And but it doesn't give us complete as a does not give information as completely as a longitudinal study can offer. But in cases where we can't use a longitudinal study and we want more information than a cross-sectional study, a sequential study is pretty good. Whew. So that is the single case quasi-experimental and developmental research chapter. This is good for qualitative research, especially if you're doing a study that's kind of mixed, where you're going to measure some kind of qualitative data, but you want to maybe measure the frequency that something occurs over time. Completely reasonable to use for that purpose. If you have any questions, let me know. I look forward to seeing how you're able to use this for the article response. And again, if you have questions, just feel free to reach out.